Accurate pH data can be collected when the pH meter is calibrated using a two-point method. In this method, the electrode is calibrated by using two different buffer solutions that are accurately prepared.
First, remove the electrode from the storage solution and rinse with distilled water and gently blot dry.
Place the electrode in the pH 7 buffer and gently stir the solution. As you can see, Natalie adjusted the pH reading on the meter to 7.
Be careful not to bump the electrode against any hard surface. Remove the electrode and rinse with distilled water. Gently blot dry and place the electrode in the second buffer solution with the pH of 4. Gently stir and adjust the pH reading on the meter to 4. As you can see, Natalie calibrates the pH meter to 4. The meter should now be calibrated and ready to use. Once the pH meter is calibrated, the pH of different solutions can be measured. Immerse the electrode in the solution, stir gently and wait for the meter reading to stabilize before recording the pH. This can be seen in the video when the pH of the first buffer solution is measured. Once you are done measuring the pH, remove the electrode, rinse the tip of it with distilled water and gently blot dry. Afterwards, the pH of the unknown, the orange juice, is measured and recorded in the lab notebook once a stable measurement is observed. Once you are done using the meter, you rinse the electrode with distilled water, gently blot dry, and place it back into the storage solution.
When comparing weak and strong acids, there is a difference in their proton dissociation behavior. A strong acid will fully dissociate in water to form hydronium ions. This reaction is non-reversible, meaning equilibrium will not occur. After dissolution, only a very small concentration of the strong acid will remain in the solution. A weak acid, however, undergoes a reversible reaction, which can lead to equilibrium, as it only partially dissociates. A weak acid reacts with water to produce hydronium and a conjugate base of the weak acid at equilibrium. For strong acids, the value of Ka is greater than 1, and for weak acids, Ka is less than 1. To minimize the effect on pH, buffers can be used.
Buffer is a solution that resists changes in pH when limited amounts of acid or base are added to it. A buffer solution consists of a mixture of a weak acid and its conjugate base, or a weak base and its conjugate acid. A buffer is able to resist pH change because the conjugate acid and conjugate base are both present in appreciable amounts at equilibrium, and are able to neutralize small amounts of other acids and bases when they are added to the solution. Buffer solutions have a working pH range and capacity, which dictate how much acid or base can be neutralized before pH changes, and the amount by which it will change.